So you have this model of a unit cell with zinc and oxygen. Now you're asked to find what the formula is for zinc oxide. Now clearly from the charges we can just say that, oh, it's just zinc oxide. Well, what if we were to do it when we didn't know what the charges were? Say we didn't even know what the elements were. Then we have to do something called coordination numbers. So we have to find the coordination number for both zinc and oxygen, and we can figure out the ratios between each other through that. So say let's start off with oxygen. With oxygen, we have 1, 2, 3, 4, 5, 6, 7, and then a corner that we cannot see in the back. So that's 8 corners. Now, if we're looking at this corner, we're only seeing 1/8 of the sphere. That means we're seeing 1/8 of the atom. So if we're seeing 1/8 of this atom because it's on a corner, and we see 8 of them, we'd have to do this. 1/8 of the atom times 8, that we have 8 of them. We're going to calculate the coordination number. Then let's look at the faces. We see that this is a face-centered structure. So we see that we have 1, 2, 3, 4, 5, 6. So we have plus 6 times faces. Now, with the faces, it looks like a half sphere. So we say that we're seeing 1/2 of the atom. Now, is there any more oxygens that we see? No. So if we add this up, this adds up to 1, and this adds up to 3. So we get 4. Now let's do the same thing for zinc. Zinc, we see the whole atom in the entire unit cell. So we have 1, 2, 3, and 4 full atoms in the unit cell. So we see 4 times a whole atom in this entire unit cell. So our coordination number is 4. So if zinc is 4 and oxygen is 4, we put those together. That's zinc 4, oxygen 4. That's a 4. So if we simplify this is just zinc oxide. And that's exactly what you would get based on the charges. So if this was an unknown lattice structure and you were given one of them, you could figure out what the element is based on these ratios using the coordination number.